Alright, so in this problem, I have x to the power of 4 plus 4 is equal to 0. So to solve this problem, I'm going to start by adding as well as subtracting 4x squared on my left-hand side. So now I'm going to have x to the power of 4 plus 4x squared minus 4x squared is equal to 0. So 4x squared minus 4x squared is simply 0, so this doesn't really do any illegal changes. Now, I'm going to rewrite this as x squared to the power of 2. I'm going to write x to the power of 4 is x squared to the power of 2, plus 4 I'm going to write as 2 squared, plus 4x squared I'm going to write as 2x to the power of 2, and I'm going to put this in parentheses, and at the end, I simply have minus 4x squared is equal to 0. Now, if I factor this, I get x squared plus 2 squared minus 4x squared is equal to 0. And 4x squared, that's the same thing as 2x squared. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So this is going to equal x squared plus 2 plus 2x times x squared plus 2 minus 2x. This is equal to 0. So now this gives me two equations. I have x squared plus 2x is equal to 0, and I have x squared plus 2 minus 2x is equal to 0. So to solve these, all we have to do is simply plug these into the quadratic formula. So I'll rewrite this as x squared plus 2x plus 2 is equal to 0, and I'm going to write this as x squared minus 2x plus 2 equals 0. So I'm actually not going to waste your guys' time and put these in the quadratic formula. I'll just say that x, if you go ahead and simplify, plug this into the formula and simplify, you get that x is equal to -1 plus or minus I. So these are the two solutions for x squared plus 2x plus 2 equals 0. And for x squared minus 2x plus 2, you get x is equal to x is equal to I plus or minus 1. So my four solutions are -1 plus I, -1 minus I plus 1, and I minus 1. Alright, so I have 3 to the power of x plus 9 to the power of x is equal to 27 to the power of x. So to solve this, I'm going to first rewrite 9 here as 3 to the power of 2. So now I have 3 to the power of x plus 3 squared to the power of x is equal to 27. I'm going to rewrite as 3 to the power of 3. So equal to 3 to the power of 3 to the power of x. Now I can actually switch the places of these two as well as these two. So now I'm going to have 3 to the power of x plus 3 to the power of x squared is equal to 3 to the power of x to the power of 3. Now if I let 3 to the power of x equal to the variable t, I'll have t plus t squared is equal to t to the power of 3. So now if I rewrite this, I can have t to the power of 3 minus t squared minus t is equal to 0. So now if I factor out t from this, I get t times t squared minus t minus 1 is equal to 0. So now this gives me two equations. I have t equals 0, which is already a solution, and I have t squared minus t minus 1 is equal to 0. So to solve t squared minus t minus 1 equals 0, all I have to do is plug this into the quadratic formula, which is -b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is equal to 1, b is equal to -1, and c is equal to -1. So I have t is equal to -1 plus or minus the square root of -1 squared minus 4 times a, which is 1, times c, which is -1. And I have all of this over 2a, so 2 times 1. So now this simplifies to 1 plus or minus the square root of 1 plus 4 over 2, which simplifies to 1 plus or minus the square root of 5 over 2. So remember how we said that t is equal to 3 to the power of x. So let's first start with our first solution of t, which is t equals 0. So if t equals 0 and 3 to the power of x is equal to t, then that means 3 to the power of x equals 0. And this is actually incorrect because you can't take the power of a number and make it equal to 0. So this has no solution of x. So now we come over here to two solutions of x. We have 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2. So if 3 to the power of x is equal to 1 plus the square root of 5 over 2, to solve this, I'm going to first take the ln on both sides. So I have ln 3 to the power of x is equal to ln 1 plus the square root of 5 over 2. And now I can move this to the front. So now I have x times ln 3 is equal to ln 1 plus the square root of 5 over 2. Now if I divide both sides by ln 3, these two cancel out, and I'll be left with x is equal to ln 1 plus the square root of 5 over 2 over ln 3. And this is actually 1 plus or minus because the same goes for 1 minus the square root of 5 over 2. So these are my two solutions. Alright, so in this problem, I have 3 to the power of x plus x equals 30. So the first thing I'm going to do is I'm going to subtract x on both sides. So now I have 3 to the power of x is equal to 30 minus x. Now I'm going to go ahead and divide both sides by 3 to the power of x. So now I have 1 is equal to 30 minus x over 3 to the power of x. Now I can also rewrite this as 30 minus x times 3 to the power of negative x. So now I'm going to go ahead and multiply both sides by 3 to the power of 30. So now I have 3 to the power of 30 is equal to 30 minus x times 3 to the power of negative x times 3 to the power of 30. That's going to equal 3 to the power of 30 minus x, because these two exponents simply just add with each other. Now I'm going to take e to the power of ln. So I'm going to multiply I'm going to write this as 30 minus x times e to the power of ln 3 times 30 minus x, because e and ln cancel out, so everything over here simply stays the same. So now I have 30 minus x times ln 3 times e to the power of 30 minus x times ln 3 is equal to 3 to the power of 30 times ln 3. I multiply both sides by ln 3. Now this can be written as 30 minus x times ln 3 is equal to the W Lambert function of 3 to the power of 30 times ln 3. And what the W Lambert function is if I take the W Lambert function of something in the form a to the power of a times e to the power of a, this is simply equal to a. So as you can see here, I'm taking the W Lambert function of 3 to the power of 30 times ln 3. However, this isn't the form a times e to the power of a yet, so I'm going to have to change this and make it into that form. So to do that, I'm going to change this to 30 minus x times ln 3 is equal to the W Lambert function of 27 ln 3 times 3 to the power of 27. So I simply just took off 3 to the power of 3 from 3 to the power of 27. Now I can write this as 30 minus x times ln 3 is equal to w lambda function of 27 times ln 3 times e to the power of ln 3. And now I can simplify this to 30 minus x is equal to 27 because the w lambda function is in the right form, so I simply this is equal to 3. So now I have a simple equation. All I have to do is subtract 30 on both sides. So I get negative x is equal to negative 3, meaning x is equal to 3. So this is my answer.
Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. So we have 102 squared minus 98 squared. Now, if we have something in the form a squared minus b squared, an important property of algebra states that this is equal to a plus b times a minus b. So now we could think of a as 102. Oops, sorry about that. So we can think of a as 102, and then we can think of b as 98. So now all we have to do is plug in the values of a and b into this form and then solve. So a is 102, so this would equal 102 plus b is 98, so plus 98 times 102, say, minus b is 98. Now 102 plus 98. Let's go ahead and solve that first. So 102 plus 98. 2 plus 8 is 10, so we carry the 1. Now 9 plus 1 is also 10, so we carry the 1 again. And 1 plus 1 is 2. So 200 is our answer. So now we have 200 times 102 minus 98. Now that's 4. So now we have 200 times 4, and 200 times 4 is simply equal to 800. So 800 is our answer.